Let's consider how we might use our HP calculator to solve the net present value equation. We might be tempted to simply use the time value of money functions on the top row of the calculator, saying that N is equal to 4, R is equal to 5, present value is equal to negative 1,000, payment is equal to 200, and future value is equal to 1,500. Well, the problem with this is we now haven't left the calculator anything to solve for. We've used all 5 of the variables, and we've given values for each of those. There's nothing to solve for in the way that we have used the functions in the top row of the calculator before. So there's another set of functions, and these are commonly referred to as the CFJ functions, or the cash flow functions, such that we're going to be able to put in values for our cash flows. Let's look at the calculator's function rows here for a minute. So the first thing we will do is we'll go ahead and clear all. So clear all, and then we're going to set the periods per year. In this case, this is going to be annual, so 1 period per year. And then we're going to use the CFJ functions. And the CFJ functions are something that start and stop as we press the CFJ button, which is right here. And every time you use this function, you need to make sure that the calculator is cleared, because every time you press CFJ, it adds one more period of time. And if you haven't cleared the calculator, you might have put in 13 periods in your prior calculation, and now if you haven't cleared it, every time you press CF, it's going to start at 13, not at 0. And then we're going to solve for net present value. So we're going to do red net present value to solve. So let's think about what our inputs are going to be. So for our CFJs, our cash flows at time J, the first one, which will be at time 0, is negative 1,000. The next one, which will be at time 1, is 200. The next one at time 2 is also 200. The next one at time 3 is also 200. But the next one at time 4 is 1,500. And then we have to tell the calculator what our expected return is. So that's still going to be I divided by Y. And that, in our case, is going to equal 5. I think we said we were at 5%. And then we're going to solve for net present value. So let's run this through for a second. I have my periods per year set to 1, so 1,000. And I'm going to change the sign so it's negative, and that's CFJ. It tells me that it's coming at time period 0. Then 200, I'll press CFJ again, and that accepts it for period 1. If you're not changing the value, you can just continue to press the CFJ button, and it will increment to the next year. So I'm pressing CFJ again for period 2, CFJ again for period 3, and then 1,500 for period 4, or CFJ 4, and then 5 I divided by YR, and then red net present value, and I get $778.70, which, not coincidentally, is virtually identical to what we got when we did it longhand. There's about a 1 cent difference here, and that's a rounding issue between the way that we did these. So that's our net present value, and we used the calculator's CFJ functions and present value functions to get. But remember that this is simply a net present value greater than 0, which means we received more in our rate of return than we expected to, or we received more dollars of return than we expected to, but we don't know what the actual rate of return is. Well, the calculator not only has a net present value function, it has an internal rate of return function. And now the only thing I need to do is press IRR. So red IRR, and that's going to tell me what my actual rate of return was. And in this case, it's 25.189%, which doesn't surprise us because we know that we effectively received 20% per year for 3 years on our original investment, and then we received 150%. So that it was more than 5% doesn't surprise us at all. That is 25% plus similarly doesn't surprise us at all.